Welcome back, everybody, to the deep dive. We are diving deep into Six Sigma and lean manufacturing this time.
Oh, this is good stuff.
I've got like a certification guide, some case studies, even notes from a seminar I went to once. So
Wow.
we're going to help you get these core ideas so you can use them too.
I think what's fascinating is how Six Sigma and Lean, they're distinct,
Yeah.
but they work so well together, like
Right.
a power couple.
Okay, so first,
For making things better.
when should you even think about using Six Sigma?
So think about this.
Okay.
If you've got like this big problem
Mm-hmm.
and the stakes are high and you don't even know where to begin,
Right.
that's when Six Sigma comes in. It's like data-driven. You define the problem, analyze it, and figure out the root cause.
Okay, so it's like taking something big and breaking it down
That's exactly it.
into smaller steps. I can see that would help with so many things.
Absolutely.
Like you said, big work projects,
Yeah.
even cleaning my house, it's a mess.
It can even help you prep for like a presentation at work or something.
Totally. Okay, so lean comes in next.
Lean is all about cutting the waste,
Okay.
streamlining everything so
Okay.
you've got maximum efficiency.
Our source material talks about the difference between defects and waste. Defects mean things that don't meet like requirements.
Yeah.
And then waste is just using too many resources, like they use a fast food place.
Okay.
If they make a ton of burger patties before anyone even shows up,
Oh, yeah.
that's overproduction. That's just pure waste.
And that's just one kind. They call them the seven muda.
The seven moves.
They're like the seven villains
Okay.
of efficiency.
Okay.
And you've got overproduction,
Mm.
correction,
Mm.
inventory, motion, conveyance, overprocessing, and waiting.
Okay, the seven muda. That does sound ominous.
It is a little bit, yeah.
So let's take them one by one. We talked about overproduction. What about correction?
Correction or rework, it seems necessary, right?
Sure.
Fixing mistakes.
Mm-hmm.
But what if you could just prevent those mistakes in the first place?
Totally.
They give an example of a call center where claims are always sent back because of missing info. That's wasted time,
Right.
wasted effort. Don't blame the person who made the mistake.
Mm-hmm.
Maybe change the process.
So it's about preventing the fires instead of always putting them out.
You got it?
What about inventory? I'm assuming that's not stuff in my closet.
No, not necessarily.
Sure.
It can be the stacks of paper on your desk or all those unread emails in your inbox. Anything just sitting there waiting.
Oh, okay.
They say this is usually because of what they call batch processing.
Okay.
You do things in like big chunks,
Instead of as you go.
right? Like waiting until you have 100 emails before you even check.
Yeah, and then it's just this huge thing.
Exactly.
This reminds me of their example about the printing and folding machines. The printer, super fast, cranks out like 1,000 pages an hour.
Mm-hmm.
But the folding machine only does 800.
Oh,
So every hour, 200 pages are just there, taking up space.
that's classic inventory waste right there.
It is, okay, motion. This isn't like exercise,
No.
right?
It's all the extra movement that happens in a process.
Yes.
They say you can use what's called a spaghetti diagram to actually,
Spaghetti diagram.
yeah, you literally map out where people go when they're working.
I can only imagine what that would look like for me.
Oh, I bet it'd
Good
be
luck.
interesting. I'm thinking about my workday. That's a lot of spaghetti.
Yes. So much spaghetti. They have a good example about a data entry person, and they're clicking back and forth between screens.
Oh, yeah, that's a good one.
It seems small,
Sure.
but if you do it 1,000 times, it adds up.
All those little things.
They say just redesign the software.
Yeah, just make it easier. Group the fields.
Exactly. Okay, what about conveyance? Is that public transit for information?
Haha, I like that. It's basically how information or things move in a process.
Okay.
And every time it changes hands, there's a chance for delays and errors. So they give the example of a CEO who needs data. Goes down a chain of emails, then back up the same way. What if the person with the data could just send it directly?
Yeah, cut out the middleman.
Exactly.
Makes sense. Okay, overprocess.
That's doing way more than what's needed.
like adding all the bells and whistles.
Exactly.
When all you need is the base model. I do that all the time.
I think we all do. They have this funny example about painting the bottom of a shelf
Oh, I love that one.
that no one is ever going to see.
But who cares? It doesn't matter.
Waste of time.
Right, but it is about finding that balance between quality and efficiency.
And that's why the voice of the customer is so important. What does the customer want?
Right. What do they need?
Exactly.
What are their problems? Don't waste time on stuff that doesn't even matter to them.
Right.
Okay, last one. Waiting.
That one's pretty self-explanatory, I think.
Yeah. But it's crazy how much time is wasted just waiting
Not
for
well.
information machines.
Projects stuck in limbo.
It all adds up. They have this example about a cashier shift change. The new cashier can't start until they swap out the cash drawer.
Oh, I see what you're saying.
Seems small, but in a busy place, that really adds up.
It's like waiting on hold with customer service forever.
The worst.
All that time wasted.
Okay, so we covered the 7 muda. Are there any other villains lurking out there?
Well, they also mention muda of talent.
Yeah.
That's when someone is not using their skills, their full potential.
It's like having a sports car and only driving it in first gear.
Exactly.
I get it.
And then there's muda of ideas.
Yeah.
That's ignoring good ideas, from the people who are closest to the work.
It's like having a treasure chest and never opening it.
That's a good way to put it.
So many different ways to waste. So how do we tackle this?
Well, our source material introduces something called 5S.
5S? Is that?
Sounds like a secret society, I know.
Right?
But it's really a system to organize your workspace, to reduce waste, make things more efficient. And that could be your actual desk or your computer files.
Right. Break it down for me. What are the 5S's?
Okay, so the 5S's are sort, straighten, shine, standardize, and sustain.
Sort, straighten, shine, standardize, and sustain.
Got it.
Okay, I'm intrigued. Tell me more.
Okay, imagine the office copy room.
Okay.
Total disaster. Papers everywhere, that old fax machine no one uses.
Yeah.
Stapler buried under a pile of who knows what.
It's always a stapler.
Sort is all about just getting rid of the junk.
Makes sense.
Find a home for the stuff you actually need.
Spring cleaning?
Kinda, yeah. It's straightened.
Okay.
Everything has its place. Labeled shelves, color-coded folders, that kind of thing.
So I don't have to dig through drawers for 20 minutes.
Right. You just know where to go.
I like that. What about shine?
Keep things clean.
Okay.
Wipe down surfaces, organize cords, make sure everything's working. If it's your computer, maybe organize your files, delete duplicates.
So you can have a naming system so I can actually find things.
Yes, exactly. No more searching for hours.
Because I named it something weird 6 months ago.
Exactly.
Okay, we sorted, straightened, shined. What's next?
Standardize.
Okay.
So how do you make those good habits stick? Checklists, write down procedures.
So everyone's on the same page.
Exactly. It's about making those habits just part of the culture.
It's not just a one-time cleanup. It's about making a system
You got it.
that keeps it going.
Right.
And lastly, sustain.
Sustain is making sure that 5S is just built into how things are done.
Okay.
Leadership commitment, training, keep checking to make sure everything is running smooth.
So it's about really changing the culture, making everyone think about efficiency.
That's a big part of it.
That's powerful stuff. Okay, shifting gears a bit, what about just-in-time manufacturing?
Just in time,
DIT?
you get things or produce things only when you need them.
Okay.
That way you minimize waste and how much you have to store.
They use the example of a factory where one machine makes parts for another machine. With JIT, they don't make a ton of parts ahead of time. It makes them just as the second machine needs them.
Right, so it's all in sync.
Totally synchronized. They talk about how JIT has changed with technology, like print-on-demand books, or even using data to see what people want so you don't make too much stuff.
Makes you more flexible, more responsive.
It's like ordering groceries online. You get exactly what you need.
Yeah, and they just show up.
When you need them. Okay, we've covered a lot here. Six Sigma, Lean, the 7 muda, 5S, JIT. What's next?
Well, next we're going to talk about some key Six Sigma concepts and tools
Okay.
that will help you measure and analyze your processes.
Get ready for some aha moments.
I think so, yeah. We're going to unlock the power of data.
You're right, let's do it. Okay, so we've got these ideas for making things better.
Yeah.
But now our source material digs into some Six Sigma concepts for measuring and analyzing processes.
Right, because you can't improve what you don't measure, right?
Right. It mentions standard deviation for understanding variation.
Okay, so remember, Six Sigma, it's all about getting rid of defects, improving quality, and to do that, we need to measure how much variation there is.
Because variation leads to defects.
A lot of times, yeah.
They use this example about baking cookies.
Okay, I like cookies.
Me too. Imagine you're following a recipe, but your oven temperature is all over the place. You're just guessing with the ingredients.
Your cookies are going to be a mess.
Yeah, some are burnt, some are raw, some are too sweet.
Yeah, that's variation.
Total variation.
Standard deviation gives us a way to measure that, like how spread out all the data points are from the average.
Okay, so
Does that make sense?
it does, it does. But they also say that just reducing variation isn't always enough.
Right. What if your oven's always too hot
Yeah.
and you always use too little sugar?
You'll have consistent cookies, but they'll all be bad.
Exactly. So it's not just about consistency.
Right.
It's about consistency around the outcome you actually want.
That makes sense. Thankfully, the source material says we don't have to calculate this by hand.
Okay.
Tools like Excel can do it for us.
Thank goodness for that.
Yeah, but it's still good to know what it's measuring, right?
Yeah, it's basically the average distance between each data point and the average. Gives us a single number that shows us how spread out everything is.
Okay, that makes it a little clearer.
I hope so.
They give an example about a teacher analyzing test scores.
Okay.
The average score is good,
Mm-hmm.
but the standard deviation is high.
So what does that mean?
It means some students did great and some totally failed.
Oh.
So the teacher knows there's a problem.
Right, like a big gap in understanding. They need to figure out how to address that.
Exactly. Okay. Standard deviation helps us see how much variation there is.
Hmm.
What about this Pareto Principle? Is that a person?
No. Uh-huh. Okay, good.
It's also called the 80-20 rule.
Okay.
It's all about focusing your effort.
I like
Basically, 80% of the effects come from 20% of the causes. So if we can find those big causes,
Yeah, the vital few.
we can make a big difference without getting lost in the weeds.
That's the goal.
Right, right. They have this great example about medical claim denials.
Okay.
A doctor's office is losing money
Mm-hmm.
because insurance keeps rejecting claims.
Yeah, that's frustrating.
There could be a ton of reasons, but Pareto says there are probably a few big ones.
Makes sense.
So they use a Pareto chart.
Okay.
It's like a bar graph that ranks the causes
Mhm.
from most to least common.
Okay.
In this example, the top 3 reasons were duplicate claims, missing information, and late filing.
Oh, wow.
And get this, those 3 reasons accounted for 80% of all the denials.
That's a lot.
It's a lot. So if they fix those 3 things,
Yeah.
they're pretty much good.
They solved most of the problem without having to worry about every single little thing
Right. So we're focusing on the stuff that really matters.
and not wasting time on the small stuff.
Okay, speaking of focusing on what matters, our source material talks about the voice of the customer.
VOC.
USC.
It seems obvious, but you'd be surprised
Yeah.
how many companies don't actually listen to what their customers are saying.
Right, right. So they have this big table of ways to get customer feedback,
Surveys, focus groups.
focus groups, even online reviews.
You want that whole picture of what the experience is like?
Yeah. They talk about Kroger, the grocery store.
Oh, yeah.
Their surveys ask very specific questions about the employees, the store, how long the checkout lines are.
It's targeted, right.
It is, yeah. I always fill those out. But sometimes you need more specific feedback, like if you're making a new product.
Yeah, you might use a focus group for that.
Or beta testing.
Right, let people try it out.
Yeah, and tell you what they really think.
Exactly.
They make this analogy about VOC being like a smoke alarm.
Oh, I like that.
It's an early warning.
Yeah, if you start seeing negative feedback, something's wrong.
You gotta fix it before it becomes a huge fire.
Exactly.
Okay, now our source material mentions some more Six Sigma metrics.
Okay, hit me with them.
EPMO, DPU, FTY, RTY, a lot of acronyms.
That's a lot.
It is. We won't get into the math too much. But basically, they're just different ways to measure defects and how well things are working.
Okay, give me some examples.
So DPMO, that's defects per million opportunities.
Okay.
That tells you how many defects you can expect per million chances for a defect.
So like 1 in a million chance.
Kind of. They use the example of a mail order company. Every blank on the order form is a chance for an error.
I see, okay.
So they track DPMO.
See how many errors are slipping through.
Exactly. DPU, that's defects per unit.
Okay.
That tells you how many defects are in each thing you inspect, like how good is the quality overall.
Okay, so a book publisher.
Right.
They're checking for printing errors, missing pages, stuff like that.
DPU tells them how many defects there are per book.
So they can track whether things are getting better or worse.
Exactly. Then we have FTY,
Okay.
first time yield.
What's that?
That's how many units go through the whole process without needing any rework.
So it's about how smoothly everything's flowing.
It is, yeah. Imagine a process with 3 steps.
Okay.
You multiply the FTY for each step to get the overall FTY.
Okay, so if one step has a really low yield, it messes up the whole thing.
It does. You got to look at the whole system.
Right, not just one part.
Exactly. Lastly, there's RTY,
RTY?
rolled throughput yield. That takes rework into account.
Oh, interesting.
So your first time yield might look good,
Mm-hmm.
but if RTY is low, that means you're doing a lot of fixing behind the scenes.
Right, and that's still wasteful.
They compare it to a leaky faucet.
I get it,
Yeah, you can keep the sink from overflowing.
but you're still wasting water.
Still wasting water.
Okay, we've got ways to measure variation, defects, how well things are running.
Yeah, sounds good.
But how do we actually find and tackle those problems in the first place?
Well, that's where Six Sigma's problem-solving structure comes in. Define the problem before you even think about solutions.
Got it. They talk about this concept YFX.
Sounds complicated.
It does, but it's not too bad.
Okay.
Think of it this way. The problem, that's Y,
Okay.
is a function f of its causes, which are x.
So the problem is caused by specific things.
Yes. If we know what those x factors are, we can start to fix it.
Okay, that makes sense.
Yeah.
What's the example?
They use an HVAC company.
Okay.
Service calls are taking way too long.
Oh, no.
The manager finds out some technicians are chatting too much with customers.
Oh, no, that's not good.
And some are new and need more training.
Okay, so the problem
Yeah.
is longer service calls.
And it's caused by too much talking and not enough training.
Right. You could write it out like an equation, extra time, F,
Yeah.
too much talking, inadequate training.
Makes it very clear.
Right like that.
So once you define the problem, you can dig deeper.
And to dig deeper.
They have this great brainstorming tool called the 5 whys.
Okay, that sounds fun.
You keep asking why until you get to the root cause.
It's like a little kid who just learned the word why.
Exactly.
Why?
Why?
Why? They use an example of customers hating hamburgers.
Very
First, why?
Yeah.
Why are they unhappy?
Yeah.
Because the hamburgers are undercooked.
Right.
Second, why? Why are they undercooked?
Yeah.
Because the grill's messed up.
Mm.
And you keep going.
Until you find the real problem.
Like in a detective show.
Right. So you don't just jump to conclusions.
Okay, we've got the problem. What's next?
You got to put together a problem statement. This isn't just saying what the problem is.
Right.
It's about presenting it in a way that will get people's attention.
They compare it to an elevator pitch.
Yeah.
You got to hook your audience.
It's true.
Your boss, your team,
Yeah.
even yourself. Show how big the problem is, why it matters.
And they actually provide a checklist for writing a good problem statement.
Okay, what's on it?
Where's the problem happening? When's it happening? What process is involved?
Oh,
How are we measuring it?
Mhm.
And most importantly, how much is it costing?
They have examples of good and bad problem statements.
Yeah, so a good one.
Might be.
Okay.
In the first quarter, the California Distribution Center had a 13.8% return rate, costing the company an extra $372,000. Wow, that's specific.
It is. It shows the impact.
Gets your attention.
Right. A bad one would just be customers are unhappy.
Yeah, that tells you nothing.
It doesn't tell you anything. And they point out that being specific can help prevent something called scope creep.
Scope creep.
Yeah, it's when projects just keep growing and growing.
Like out of control.
They use an example of a team reducing package returns.
Okay.
They realize the packing process is really wasteful,
Mm-hmm.
but that's a whole other problem.
Right, it's out of scope.
It's like you start cleaning your closet and you end up renovating your house.
That happens to me all the time.
So we've learned about YFX, the 5 whys, and problem statements. What's next?
Well, next we'll look at some strategies and techniques
Okay.
for actually fixing those problems.
Okay, so
Yeah.
we've spent a lot of time on how to define the problem.
Right, but that's just the start.
So how do we actually fix it? Our source material goes into that.
Yeah, and this is where Six Sigma shines, because it gives you a whole toolbox of methods and strategies.
Mm.
One that they highlight is DMAIC.
DNAIC.
It stands for Define, Measure, Analyze, Improve, Control.
A lot of acronyms.
I know, right?
It makes sense.
It's a step-by-step approach to solving problems, improving processes, and it's all based on data.
So we've already done the define part.
Right.
What about measure? I'm guessing this is where those 6 Sigma metrics come in.
You got it. In the measure phase, you're collecting data to see how the process is actually doing right now.
So you can see where you're starting from.
Right, you might use process mapping, data collection tools, statistical analysis.
It's not just about saying, oh, this seems slow.
Right, it's about getting the numbers.
So you can track progress and make decisions based on, facts.
Exactly, moving from opinions to actual data.
Okay, so then you have all this data.
Right, and that's where analyze comes in.
Analyze, okay.
You're looking for patterns, trends, root causes.
Like a detective.
Exactly. You might use Pareto charts, cause and effect diagrams, more statistical analysis.
To figure out what's really going on.
And why?
And once you know the root cause,
Then you can brainstorm solutions.
that's improve, right? This is where it gets fun.
It is. They recommend things like redesigning the process or making it so mistakes are less likely to happen.
Mistake proofing. Interesting.
Yeah, and even automation.
Okay.
But the important thing is you got to test your solutions on a small scale first.
Don't go all in right away.
Right. And make sure you're tracking the results so you can see if it's actually working.
Because what's the point of all this if it doesn't make things better?
Exactly. And that brings us to control. This is all about keeping those improvements going long term.
Not just a one-time fix.
Right. They recommend standard procedures, training programs, regular check-ins.
To keep everything on track.
Right.
It's like building a house.
Oh, I like that.
You don't just put up walls and call it a day.
Right, you need a good foundation.
And then you got to keep maintaining it.
DMAIC provides that structure.
For not just solving the problem, but making sure the solution actually lasts.
That's it.
This deep dive has been amazing.
It has.
We went from these core ideas of Six Sigma and Lean to tools we can actually use.
Right, to solve problems, improve things.
I feel like I have a whole new way of thinking about challenges.
And the cool thing is, this isn't just for factories or businesses.
Right.
It's a way of thinking that you can use anywhere.
So to our listener, we challenge you.
Yes. Think of a problem you're facing at work, at home, maybe even a personal goal.
Try using what we've talked about today.
Ask the 5 whys.
Create a strong problem statement.
Gather data.
You might be surprised what you learn.
And remember, this journey of improvement, it never really ends.
There's always something new to learn.
Always a way to make things better.
Thanks for joining us on the deep dive.
Until next time.
Keep learning.
Keep questioning.
And keep diving deep.